Okay, last problem from section 311. So wrapping this up, we're going to do example 5. So example 5 says Farmer John's tractor. So Farmer John tractor traveling at 3 meters per second. Pulls a rope attached to a bale of hay. Through a pulley. They give us a picture with dimensions. They say how fast is the bale rising? So how fast is the bale rising when the tractor is 5 meters from the bale? Okay, so they give us this picture here. We got a tractor sort of thing. Some sort of tractor, I guess. It's got a little guy on it or something. Got some sort of pulley here. So there's a rope that connects to the pulley, connects down from the pulley to our hay bale. We get, here's the ground. The distance from the ground to the height of the hay bale we call h. So therefore, from here up to there, they tell us that that's 6 minus h, the distance from the top of the hay bale to the top of the pulley. Then they tell us the tractor is a distance x over from the pulley. And then this vertical distance that we have here, they say that that's 4.5. And the tractor is moving at 3 meters per second. So we need to figure out what relates. We're trying to figure out how fast is the hay bale rising. So how fast is the hay bale rising is asking us for dh dt. They gave us dx dt. They gave us x. So we need to figure out how do we relate this x here over to this h. And what I'm going to use is I'm going to look at the length of the rope. If I can build an equation that's basically the length of the rope here, then I can put that together and then that'll relate everything to everything else. So I'm going to say length of rope. I'll call that L of x. That's going to equal the diagonal section of rope. And we're going to add to it the vertical section of rope. So the diagonal section of rope, we can get that value using the Pythagorean theorem. So that's going to equal the square root of, it'll be x squared plus 4.5 squared. And then we're going to add to that the vertical section of rope is length 6 minus h. So this is our length equation, I guess we could say. What we're going to do is we're going to take ddt of this whole expression. X is going to change with respect to time. The height will also change with respect to time. Everything else should be constant. Oops. Want to take ddt of the whole thing. So I'll get dl dt. It's the rate that the length of rope changes, equals 1/2, leave the inner part alone, to the negative 1/2. ddt of 6, that's a constant, so it goes away, and we get minus dh dt. Now, if we think about this, the length of the rope, as you pull this through, the rope doesn't get like longer or shorter. It's just the rope stays the same length the whole time. It's just the amount that's diagonal will increase, but then the amount that is vertical will decrease at the same amount. So the length of the rope change with respect to time is 0. The rope doesn't actually change with respect to time. I'm going to kind of simplify this back to square roots. Okay, I made a mistake here. Let me go back up here. So when I took the derivative of this, it was 1/2, leave the inner part alone, to the negative 1/2. The chain rule applies. I need to multiply this by the inner derivative. So I did the first part of the chain rule and forgot to finish it off. This needs a 2x dx dt after it. That's the derivative of x squared plus 4.5 squared, which is the inner part from the chain rule. So down here, chain rule should have applied. Down here, what that means is the 2x dx dt is up top. Or we could say 2x there, dx dt off to the side here, minus dh dt. And then we'll note, hey, the 2 here and the 2 there, those can cancel. The dh dt, what we're trying to solve for, the rate that the hay bale moves up, we're going to slide that across the equal sign. So we get dh dt equals x over square root of x squared plus 4.5 squared times dx dt. So now let's try to plug in values for this. They said we're looking for the rate the hay bale rises when the tractor is 5 meters from the bale, which means x is 5. So what we're looking at here is what is going on when we put 5 in for the x's. And then dx dt, that's the rate that the x direction changes with respect to time. That is the tractor speed, because the tractor speed is driving in the x direction. So that will be 3 meters per second going in there. And then basically what we get is dh dt should equal 5 over the square root of 5 squared plus 4.5 squared, all that times 3. So we'll type that in, check that against the book, make sure everything's looking correct. If we made a mistake, see if we can figure out where we went wrong with it, but I believe we're all good here. So we get the height that the hay bale raises is 2.298 would be 2.30. And then the units on this, let's see here. It's meters, time is meters per second. So the units on this should be meters per second. Let's check this against the book. Book says 2.23. We got 2.230, same thing, so we're doing good. This is the rate the hay bale rises when x is 5. So, okay, that'll wrap this section up. So we'll stop.